All right, we're on page 28 of our notebooks. It is quadratic equations and functions. Please make sure that you get down the goal. Okay, we're using page 27 for your prep work, so make a note of that. So when you get it back, you have that. But on page 28, we're starting quadratic equations and functions. You guys are going to be able to graph and solve quadratic equations. Now, this should be a review. Okay, we've been solving quadratics ever since we were in Algebra 1. We did them a little bit in geometry when you got to those kind of more challenging problems when you got the circles. And of course, we did in Algebra 2. We delved a little bit deeper into quadratic equations as well as functions. So honestly, guys, hopefully this lesson is going to be a review for you all. All right? We're going to look at our foldable next. We're going to hold off on the cutting until after everyone has it, so I can only explain it once. So, definition, a quadratic function is one of the form of y equals ax squared plus bx plus c. Its graph is in the shape of a parabola. Okay? That is a quadratic function. So, what is a parabola? What shape is that? It is a U. Okay? A U can point up or it could point down. Okay, but every quadratic can be written in the form of ax squared plus bx plus c. Okay? So like if you have an example like this right here is the ax squared. So a is basically the coefficient of this particular term. Bx, and then you have c. Okay? That's the layout. Now, do you always need to have a bx term? No, but in order for it to be a quadratic, you definitely need to have an a. Okay, or else you're just dealing with something else. And this is known as standard form. Okay, when A, B, and C are all on the same side, this is known as standard form. There are different forms of quadratics. We won't harp onto them just yet. That's for later on in the year. But this is the general makeup. Okay? Now, your y-intercept. Okay? You can find that by basically plugging in 0 for x into the standard form. And the y-intercept is basically where the graph crosses the y-axis. So the equation is in standard form. Basically, the y-intercept is just the c. It's whatever this number is at the end when it's in standard form. Okay? Whenever it's in standard form. Okay? So, looking at this example, find the y-intercept of y equals x squared minus 2x plus 3. What's the y-intercept? It's just 3. If you forget that it's just the last number, remember you can plug in 0 for x and solve. Basically, this term cancels out, this term cancels out, and you're left with 3. However, y-intercepts, just like x-intercepts, are written as points. Okay? So even though, yes, 3 is where it crosses the y-axis, we always write our y-intercepts as points. So what's going to be the point? 0, comma 3. 0, 3. Okay, simple as that. Just for the sake of the video. All right. Questions on that? But again, asking in standard form, so don't let it throw you off it. Next thing we're going to talk about is how to graph a parabola. Okay? Yes, there are some extra notes down here. You can squeeze them in wherever you feel necessary. A lot of it is just fluff. So get down what's important out of those lines at the bottom. But hold on, don't write them down just yet. We're going to graph it first, and then you can write it down, okay? Because the purpose of those lines is after we graph it. So, to graph a parabola, or to graph any type of function, what's the easiest way? XY chart, a T chart. Yes. Make a chart, make a table of values. This is the easiest way instead of trying to figure out, what are my x-intercepts, and that involves like extra stuff. Make a table. The easiest way. Any function. And it's always kind of good to make sure you pick a variety of different types of numbers. What are some numbers you can pick? Say again. -2. -1. 0. 1. 2. Yes, pick some negative numbers. Pick 0. Pick some positive numbers. That way you can kind of have an idea at least, and it should be forming a U. All right? And then to find our y values, what do? Plug it in. So -2 squared Positive 4. So we have 4 plus 4 plus 3, 11. That's kind of outside of my graph. Okay, somewhere up in this nether region. Okay, let's plug in negative 1. Negative 1 squared. And then minus 2 times negative 1. So we have 1 plus 2 plus 3. 6. I think I can graph that. Negative 1, 6. We plug in 0, which you already know automatically. 3. It is our y-intercept. We plug in 0 for x, we get 3 for y. When we plug in positive 1, we get 6. Sure? Gotta be careful. Negative 2 or positive 2? Positive 2. And when I plug in 2, okay? It doesn't look like it's turning. It has a turning point where it's going to go back up. There we go. We have enough points now to graph our quadratic. Okay? And yes, I know it's going to look like a U, but I don't want you to say, hey, as long as I just draw a U, I'm good. No, no, no. When we're looking to see where exactly that turning point is, and when we're looking to see if it crosses the x-axis, you know, maybe where it's crossing there, definitely the y-intercept. Okay? So don't try to cheat me. Don't try to cheat yourself. Now, the y-coordinate of the vertex, which is the lowest point there, is either a maximum or a minimum value of the function. Okay? So when you're looking at a parabola, you're either going to have a maximum value or a minimum value. Okay? Now, if a is greater than 0, the parabola opens up and it has a minimum. Like, look at our problem here. It's x squared. A is what number? Say again? It's 1. It's a positive number, so it's greater than 0. That lets us know before we even try to graph this, it should have been opening up to begin with. Meaning that that vertex is going to be a minimum. However, if a was less than 0, being like a negative number, it would open down and it would have a maximum. Okay? Now, the axis of symmetry divides the parabola into 2 congruent halves. Okay? The axis of symmetry is an equation, which means that anytime it asks you to find the axis of symmetry, you should always have x equals. That is so crucial. That is so key. And then there's a formula to find the axis of symmetry. It's negative b over 2a. So whatever b is in your quadratic, whatever a is, you plug those in, you simplify, and you have your axis of symmetry. It's x equals whatever that number is. And one interesting thing is when you find the axis of symmetry, you actually also found the x-coordinate of your vertex. So they're related to each other. Because it's a vertical line that goes straight through your vertex and it cuts the x-axis. So it shares the same x-coordinate. Alright? So let's find the axis of symmetry for the same example. X squared minus 2x plus 3. It's an equation, so we're going to do x equals negative b. What's b? Negative 2. All over 2a. What's a? 1. Now we all know 2 negatives make a positive. So this is going to be a positive 2 over 2, which is what? So our axis of symmetry is the equation x equals 1. And that also tells us that the x-coordinate of our vertex is also 1. Okay? Questions on that? So we use negative 2 because b is, like, you take the sign with it. So then that negative and that minus turns into a positive. Others? Using that, we can actually find the vertex. The axis of symmetry is the x-coordinate of our vertex. So we can kind of look at it as the x coordinate is that negative b over 2a, whatever we get when we do the axis symmetry. The y coordinate is what we get when we plug that number in. That's what f of negative b over 2a means. So whatever that number is, we plug it into our function. That's how we find the vertex. The vertex is a point. Okay? So we're going to do that here. How do we find the x coordinate? Negative b over 2a. We just did that, didn't we? Okay, so what was that value? 1. Now to find the y coordinate, we're going to take that answer and we're going to plug it into the function. And this is going to be the y coordinate of the vertex. What is that? 2. So there's the vertex, 1, 2. And if you look at the one where it says graphing, when you flip that over, you can see that that's exactly where the graph turned, didn't it? From before? 1, 2. So that's how you find it algebraically. You find the axis of symmetry, that negative b over 2a, that's your x coordinate. Plug it in, you get your y coordinate. All right? Now, if it ever asks you to find the minimum value, the y coordinate of your vertex represents either the maximum value or the minimum value. This depends on if it opens up or down. So if the graph opens down, the y coordinate tells you the maximum value. That tells you the highest that parabola goes. But if it opens up, it's going to give you the minimum value, the lowest that parabola is going to go. Okay? The y coordinate tells you that. X coordinate tells you axis of symmetry. Questions? A lot of extra stuff. But you guys remember this, right? It's all coming back, clicking, the bells and whistles are going off. No one's head is like steaming fumes out the ears, right? Like it's overload. Okay. Last bit, domain and range. You guys should know from our parent functions, the domain is all real numbers. So you can write that in any notation you like. You really shouldn't have to write out all real numbers. And the range is all real numbers less than or equal to the maximum or greater than or equal to the minimum. So the range of a quadratic is dependent on the y coordinate of the vertex. Okay? And also if it opens up or if it opens down. So I'll say that again. The range is dependent on the y coordinate of the vertex and if it opens up or down. Because if it opens down, then it's basically all real numbers less than the maximum. So from negative infinity to that y value. But if it opens up, it's from that y value, everything greater than that y value. So from that y value all the way to positive infinity. Okay? So we're going to find the domain and the range of the function that we've been working with this entire time. Okay, we have a picture of what it looks like. Okay, we found all the good stuff, okay? What was the y coordinate of the vertex again? 2. The y coordinate of the vertex was 2. Did this parabola open up or did it open down? It opened up. So because this is a minimum, it's going to be everything from this y value and up. So everything greater than the y value. How do we represent that? Positive 2 to infinity in bracket, parentheses. What if I wanted to write it in set notation? And this is the range that we're talking about, guys. I'm sorry. I skipped domain. I wasn't even thinking about it. No, not all real numbers. Oh yeah, the domain is all real numbers. Sorry, my bad. The range is set notation. How would I write that? And x is an element of y. Thank you. What's the domain? Good stuff. And there you go. That's quadratic. I'll sum it to one nice little focal. And my pen keeps breaking up for whatever reason. This part will be quick because we're solving quadratic equations. All right, there are many ways to solve a quadratic equation, but the 3 ways we're going to be talking about today are factoring, quadratic formula, and completing the square. Yes, all of these things should be very familiar. Factoring factoring should be the most recent in your mind because we've been factoring a little bit so far. Quadratic formula, some of you guys may remember the formula, some of y'all might not, so we're going to review over that. And completing the square, I don't know if any of y'all remember how to do this, but we're going to go over that as well. Okay? No. All right, so we're going to solve these two equations by factoring. Okay? We're going to do two each, two factoring, two quadratic formula, two completing the square. And you guys remember, when you factor, you want to make sure everything is all on one side. You set it equal to 0. And in these cases, like the very first one, you want to figure out two numbers that what?
Add together equal 12.
What two numbers add to give you negative 8 and multiply to give you 12? Negative 6 and negative 2. You put an x in the front. These are the easier ones because a is not 1. After that, you apply a property. Anybody remember what that property is called? Question.
Which x are you talking about? First one or B or A? But you're like x, like the x itself?
A. A is 1. So these are the ones when A is actually equal to 1. These are no, like I consider them the easy ones because you're just looking at the two numbers and you plug them in to the bottom ones. These are. Okay, we have to apply a property. I know you guys know what to do from here.
X cannot equal 6.
You gotta set them both equal to 0. There's a property that by that name. Anybody remember that property? 3 words. What are you doing? Equal to 0. 0 is one of the words. What's the second word? It's a property. 0 blank blank. Y'all would never taught this?
Probably. I just don't remember the
But usually when you hear 0, somebody remembers. Property is the last one. What's the word in the middle? What's happening between these two factors?
multiplication.
What's another word for multiplication?
Another word. Product.
Product. 0 product property. Write this down. 0 product property is what allows you to set both factors or your factors equal to 0. Okay? Without this property, you wouldn't be able to say that x is what number? 6 and x is 2. 0 product property allows you to set both of those factors equal to 0. That's what you're doing. You're applying that property when you actually are continuing to solve for the quadratic.
Oh, I get it.
Okay.
It's usually not equal.
But in this one, it is equal. When you solve the quadratic, these x values are the values where the graph is crossing the x-axis. Okay, so when you're solving by factoring or quadratic formula, completing the square, you're finding the values where the graph is crossing the x-axis. Okay, so if I ever asked you to find the x-intercepts, just solve. Okay, now this one. Now this one. We got to get into standard form, so what do we need to do?
Subtract 2.
Subtract 2. And if we notice, this is an example where a does not equal 1. So we can't quite just go and figure out our two numbers. Depending on who you have for Algebra 2, you might have learned California method. Raise your hand if you learned California. Okay?
I remember it now.
That's all right, we'll go over it. Some of y'all might have learned this through grouping. You want to do it by grouping? Maybe your teacher just told you, hey, guess and check. That's how I learned. My teacher's like, you got to be able to recognize the factors of the first number, the factors of the second number, and figure out the combination that add to give you the one in the middle. Sucked. But since I started teaching, you know, we've learned so many other ways. Honestly, I feel like California is the best way.
I love it, California.
And some of y'all might have did, hold on, listen, slide, divide, bottoms up. That right?
That's for
No, smiles, X's, crosses, okay?
Too many words.
These are all different names by teachers at this school who taught factoring, okay? But California, in my opinion, the easiest one. You start by multiplying A and C. So what's 3 times negative 2?
-6.
-6. Now from here, you find your two numbers that multiply to give you -6 and add together to give you 1, your B term. 3 and what? 3 and -2. Okay? You're looking for, again, two numbers that multiply to give you the product, add together to give you the B term. This number right here. So we get them, 3 and -2, and then we create a fraction. Who remembers what we put on top? Oh man. You gotta put a 3x on top. Whatever A is, you put it on top. And you put an X along with it. And then you reduce. X over what? X over 1. Can you reduce this one?
No.
No. So your two factors are x plus 1 and 3x minus 2. And you put them in parentheses. That's how you factor when A is not 1 using California. Okay? Apply zero product property to get my two solutions. Do that now. What are they?
-1.
Very good. Make sure you set both of them equal to 0. And there you go. Your two solutions. So it's crossing, for this particular quadratic, it's crossing the x-axis at -1 and the x-axis at 2/3. Questions on factoring or solving by factoring. Came back to you? Remember? I was like, the first one you guys should remember because you've been doing that since domain and range. Okay? Completing the square. We're doing that one next. Okay? Completing the square, that one's next. Okay, this one is probably the one that has the most steps and things to remember. Okay? Let's see. 4 steps? Think about 4 steps. First step is you want to make sure that C is by itself. So if it's in standard form, you want to make sure that C is on one side by itself. Okay? So get C alone. How do I do that here? Minus what? Minus 1. And in the same token, you want to make sure that A is equal to 1. Is A equal to 1?
Yes.
Yes, it is. If it wasn't equal to 1, you basically would have to divide by whatever A was to get it by itself. To get rid of your A. Now the next step is you take half of B and you square it. Okay? And then add it to both sides. Okay? My B term is a -4. What's half of -4? When you square it, you get 4. And that's what you add to both sides. Basically, by doing that, you are making the left side of your equation a perfect square trinomial. And that's what you want to do. That's why it's called completing the square. You're creating a perfect square trinomial. Okay? The last step is simplify and solve. Okay? Now, simplifying the right side is pretty easy. Okay? What is -1 plus 4? 3. On the left-hand side, you're going to factor this. You're going to factor that. What two numbers multiply to give you 4, add together to give you -4? -2 and -2. So you basically would have x minus 2 times x minus 2. How can that be written? That's what's talked about with simplifying. Basically, the left side will always turn to a perfect square trinomial. Okay? And if you're ever wondering, this number right here is always what you get when you take half of B. Every time. Okay? Now solve for x. How do you solve for x? Do what? Take the square root of both sides. And you have to remember, when you take the square root, you'll get plus or minus on the other side. Last thing. Oops, sorry, got a square root. Add 2. And that's your answer. Okay, that's some decimal where you're crossing the x-axis because the square root of 3 is not a perfect square. And that is completing the square.
What do you do if it doesn't divide evenly?
Then you can keep the fraction, and you work with the fraction all the way throughout the problem. Okay? Yes, fractions. Okay? So, were you referring to the next one? Yes. So the first step, get C alone. Is C alone? Yes. Is 8 equal to 1? No. So to get A to equal 1, you have to do what? Divide everything by 3. Not just this term, but every single term you divide it by 3. And when you do that, what do you get? Excellent. -4/3. So yeah, you're going to be working with a fraction in this one, but that's okay. You guys are at this level for a reason. That means you can actually work with fractions here. Okay? So now what's the next step?
A over 2.
B over 2. What's B? -4. Divide that by 2. What do you get? -2. And then you square it. What's -2 squared? 4. So you're going to add 4 to both sides. Last step, you have to simplify and then solve. Well, since this is basically the same setup as the last one, we already get the left side factors down to be what? But what is -4/3 plus 4? How do you add a whole number to a fraction? Not greatest, but lowest. Lowest common denominator. It's going to be 3. What over 3 gives you 4? 12. So 12 over 3 is basically 4. Then you just add. What's -4 plus 12? 8 over 3. There we go. You're okay. Yes. Okay? Can you guys take it from here? I'll check back in and see if you got the same answer. Solve for x. I think everyone has taken the square root. Yeah? And the thing is, when you take a square root of a fraction, you're taking the square root of the numerator and you're taking the square root of the denominator. So over here you'll have x minus 2, but over here you have the square root of 8 over the square root of 3. How do you get that square root at the bottom? Rationalize. How do you rationalize? Multiply the top and the bottom by the bottom. So that square root of 3 you multiply to the top as well as to the bottom. What's the square root of 8 times the square root of 3? Square root of 24. And what's the square root of 3 times the square root of 3? Square root of 9, which is just 3. So right now we have x minus 2 equals the square, plus or minus, of course, square root of 24 all over 3. You have to add 2. But you're still not simplified just yet. You can break down the 24. How does 24 break down? 2 on the outside, 6 on the inside. So our final answer is 2 plus or minus 2 root 6 all over 3. And I know it's kind of hard to see because I ran out of space already too big. Quadratic formula. We're going to do these two problems using quadratic formula. But in order to do this, we need to know that's my version. Plus or minus square root, Yeah. It's perfect. Okay, everybody participate. Here's your brain break. Here we go. Yes, yes. And I will make you out. And we gonna get this all on video. You better believe it. So you better do it right the first time so we can stop. It's a call and response. I start, you go. Here we go. Negative b.
Negative b.
Plus or minus square root.
Plus or minus square root.
B squared minus 4ac.
B squared minus 4ac.
All over 2a.
All over 2.
One more time. Negative b.
Negative b.
Plus or minus square root.
Plus or minus square root.
B squared minus 4ac. All over 2a.
All over 2.
Let me do it right. All right.
Somebody.
You got a Billy Bound killer.
What's that?
Square root.
Is that one?
No.
What's that one?
You gotta make that square root.
I don't know.
You're recording this.
I know. A, C, all over 2A. That's the quadratic formula. What do A, B, and C stand for? Standard form, and they're the what? Coefficients. For this first one, what's A? 1. What's B? And C? 15. Go ahead and plug it in, simplify. Let's see if we all get the same answer. All right, so you plug it in. Negative b turn into a what? A positive 4. Plus or minus the square root. B squared is minus 4ac.
Wait, no, 14. Wait, what? 16. You got 44.
60. All over 2. Now 16 minus 60 turn into a what? Negative 44. Who remembers that when you have a negative underneath the square root, what do? Pull out an I. It's imaginary, so you pull out an I whenever there's a negative underneath the square root. And then you simplify 44. How does 44 simplify? 11 and 4. Isn't 4 a perfect square? Pull that out. So it's going to be minus all over 2. Can't you simplify this sum? Since everything is divisible by 2 that's on the outside of the square root, your final answer is going to be x equals 2 plus or minus I root 11. Okay? Do the second one. But you got to make sure what before you start the second one? Move something to the other side. Get it in what form? Standard. Last one, we have to get in the standard form. What's A? Bring it back. 3, B, and C. So when you go to plug in,
Oh, right.
bring it back, guys. Bring it back. Negative B would be what? Negative 4 plus or minus the square root. B squared minus 4ac. It would have been a negative 96, which would have turned into a because when you do 4 times A times C, it would have been 4 times 3, which is 12. 12 times a negative A, which gives you a negative 96, but it was already a minus, so it turns into a plus. All over 6. 16 plus 96 is, does that simplify? 16 and 7. So you would have had x equals, can I simplify that? Each one of those numbers divisible by 2. So it's with a negative 2 plus or minus 2 square root of 7 all over